Today we are going to talk about how can we make MLOps simple, secure, and cost-effective. So today, me and my colleague Jeremy are going to talk about how can we make MLOps simple, cost-effective, and secure. So when people hear about AI, they think about self-driving cars or computers beating humans on games like chess, or AlphaGo, or Jeopardy, or talking Siri and Alexa. However, for data scientists and ML engineers, a lot goes behind the scene in building those AI/ML applications. A lot of skills are needed to build an end-to-end AI/ML applications. For example, a data engineer may gather the data and cleans the data. Another engineer may extract features out of the data. Data scientists may use that data and the feature to build very complex models. An application engineer may expose that model as APIs. And finally, end user may use an application that is built using those APIs. So as we all know, as a practitioner of MLOps, that building ML applications is very complex and distributed. So not only that, productionizing ML code is very, very challenging. This is an example that was also showed early in the morning, that this team actually took 3 weeks to build a model, but struggled for 11 months to productionize it. And there are many, many challenges why it happens that way. And we are going to briefly review some of those challenges. So the challenges faced by MLOps team can be broadly classified into 3 categories. The first set of challenges are related to infrastructure, which are mainly faced by the platform operations teams. And here, the main challenges are providing consistent environment between on-prem and multi-cloud. The other challenge is, as an MLOps team, you have to support a variety of frameworks like XGBoost and Keras and TensorFlow, PyChart, scikit-learn, so many of frameworks and so many versions across them. You also have to provide hardware accelerators like GPUs and TPUs for AI/ML workload. The security and policy compliance are also very challenging for MLOps folks. For example, many of the AI/ML applications leverage data which often is very, very sensitive. So the access control and exfiltration control are very challenging for MLOps team. Also, we use open source frameworks to build ML applications. So making sure that it's bug-free and doing vulnerability checks on open source frameworks is also quite challenging. Essentially, you want to make sure that your supply chain of software is very, very secure. The other challenge is that there are so many teams working in parallel to build AI/ML applications, and you want to basically have organizational policy who can do what when. So how do you consistently apply that organizational policy across multiple teams and across multiple clusters, which may be distributed on a cloud as well as on-prem environment, is quite challenging. Third set of challenges are related to DevOps. So we all know that data scientists and data engineers are very, very expensive resource. So how do we make them basically very productive? How do we increase their velocity? How do we provide uniform observability across your clusters, which may be distributed in multiple cloud environments as well as on-prem? How do you basically improve the agility of DevOps environment? These are some of the critical challenges, and we are going to talk about how we intend to solve. So to solve all these challenges, you need a very, very talented ML engineers and DevOps team. And anyone who has ever tried to hire talented MLOps engineers knows that there is a shortage of them. There are only a handful of you guys. So how do we make all these scarce resources very productive? How do we give them an environment so that they can innovate faster? That's where Kubeflow comes in, and Jeremy will walk us through that.
So thank you very much, Maulin. So precisely to address these challenges, That's why we started building Kubeflow. So Kubeflow is an open source Kubernetes native platform for machine learning. So the genesis of Kubeflow is, I think this is a similar slide to what David showed this morning, is we think about building an ML application as a multi-step process, right? So you have to do data ingestion and pre-processing. After you do pre-processing and data ingestion, you have to train your model. Once you've actually trained your model, you have to package that up and actually deploy it. Then once you have that running in production, you have to figure out how you monitor that and collect logs and do all the operations, and then potentially retrain that. And so for each of these steps, you potentially need one or more applications. And so with Kubeflow, we have sort of two goals. One is to give you a set of applications to meet to satisfy the needs of every step in this multi-step process, but also make it easy for you to compose these applications into a complete and cohesive platform. So this slide gives you an idea of the applications that are part of Kubeflow today. And many of these, as indicated by the green boxes, are applications that are being developed within Kubeflow. And so we have a bunch of applications that we're developing for various phases of machine learning, such as training and tuning. So for training and tuning, we're developing a bunch of custom resources in Kubernetes to help you make it easier to train models with different frameworks like PyTorch or TensorFlow on Kubernetes, and also potentially to do distributed training so you can train really large models. For model serving, we're developing something called KF serving, which is handling tasks such as splitting traffic between like a new version of your model, like a canary, and also your existing model so that you can roll out new models really easily. It also is going to handle doing inference graphs. So if you have, let's say, a PyTorch model and an XGBoost model, and you want to combine those, you can easily do that using KF serving. We also have applications for orchestration. So one of the biggest challenges people face is that if you're building complex ML applications, you often have multi-step workflows. You might have pre-processing, then training, then deployments. So you will need a tool to express those as complex pipelines. And so we provide Kubeflow pipelines. A big challenge, of course, is tracking all of the artifacts and understanding how your models were developed. And so for that, we're providing metadata and experiment tracking. And then we also have a whole bunch of applications, which are the ones not in green, which we're incorporating and making it easy to deploy as part of our Kubeflow platform, because there's a lot of existing applications already out there. So as an example, you have the Spark operator. So this is an operator that makes it easy to run Spark on Kubernetes. So you can use Spark for ETL jobs. Similarly, TFX, which is Google's internal machine learning system, and is being open sourced, they provide a lot of different applications for different phases of machine learning, such as TF Transform, which can be used for pre-processing. And so we want to make it easy for those applications to be deployed on Kubeflow so that you can combine them into your cohesive platform. So this is what the architecture looks like. And the main point is that we're going to make it super easy to deploy these applications onto Kubernetes. And we're going to deploy these on Kubernetes in what we call a shared namespace, so that these applications can be shared among multiple users or multiple teams. And the reason we do it this way is we want to have sort of a multi-tenant architecture so that you can have a single centralized infrastructure or DevOps teams that is managing this platform on behalf of many users or many teams. And this just sort of allows a single team to scale to support a much larger enterprise with many teams and different users. But each team or user would consume Kubeflow in their own namespace. And so namespaces are a concept in Kubernetes that provide isolation. And so they provide isolation both in terms of quota. So you can say, how many GPUs should each team be allowed to use, and that allows some fair scheduling of scarce resources like GPUs. But it also provides an access control boundary, so you can make sure that one team or user is not affecting the other person's resources. So you can restrict which notebooks or models one team can access. So the key principle here, we have three key principles. The first is we want to be composable. So we want to make it super easy to use and deploy the applications that make sense. So that means different machine learning frameworks, whether that's TensorFlow or PyTorch, and also use different sort of model servers and other applications that might be useful. Scalable, we want to make it really easy to go from just training on a small data set to training large models, so either running distributed training and training on really large data sets using multiple machines, or using more dedicated hardware, like very expensive and very large GPUs, or potentially even doing scaling horizontally by doing like a hyperparameter tuning job. And finally, we want to be portable, so we want to be able to run both in the cloud and on-prem, as well as your local laptop. And that's one of the key advantages of using Kubernetes as your main underlying layer, is it provides an abstraction layer that can run anywhere. So this is just to summarize Kubeflow's mission. Our goal is to make it easy for everyone to develop, deploy, and manage portable distributed ML workloads. Right? So essentially, we want to make it easy for people to take a set of applications for machine learning and deploy them as a cohesive platform. And so there's, we already sort of covered this, but there's 3 key reasons why we think Kubernetes is critical for machine learning and is so good for machine learning. One is portability. Kubernetes runs everywhere, so it runs in all the public clouds as well as on-prem. And we hear from all of our customers that they want to be, multi-cloud and hybrid. And so using Kubernetes as that base layer for our platform really makes that easy. The second is, again, scalability. Kubernetes makes it really easy to scale out and takes care of all of the resource management so that we don't have to do that. And most Kubernetes clusters these days comes with a form of auto-scaling, so they can automatically provision additional capacity as needed based on demand. And finally, we think Kubernetes really improves productivity because it takes care of a lot of the low-level infrastructure operations, so users don't have to deal with them. For example, if machines fail, whether that's for because you're running on-prem and have hardware, or because your VMs in the cloud are ephemeral, Kubernetes can automatically fail over and move your workload onto other machines, so you don't have to deal with that. So we're growing quite rapidly as an open source community. You can see the logos here. We have over 30 companies that are participating. The number of pull requests is really just astonishing, as well as the number of unique PR authors. And so I think we're up to over 80 unique PR authors, every 28 days. We just released Kubeflow 0.6 at the end of July. So we do quarterly releases. And so here are some of the quick highlights in 0.6. One, it was the initial release of our metadata and artifact tracking solution. The second big thing was we made some significant improvements to our deployment story and using more modern deployment technologies in Kubernetes. A big ask from our customers was adding multi-user support. So before 0.6, everybody ran with the same sort of permissions, and it was really sort of a single user model. But now with Kubeflow 0.6, we can really isolate users in their own namespaces. And finally, for pipelines, we had a bunch of API and UI improvements.
OK, so now I'm going to talk about why Anthos is an ideal platform for MLOps. So first, let's talk about what is Anthos. So Anthos is Google's offer for hybrid and multi-cloud environment, which provides consistency across all the environments. So it comprises of 5 core technology pieces, and I'll walk you through one by one. So the core, the heart of the Anthos is Google Kubernetes Engine or Google Kubernetes Engine on-prem, depending on where you are running. So Google Kubernetes Engine provides orchestration of containers which run your AI/ML workload. It also provides many cool features like auto-scaling, auto-provisioning, scheduling, authentication, authorizations, and many, many other features. So that's the foundation for Anthos. The next layer on the top of that is Anthos Service Mesh, which is Google's implementation of open source Istio. So it provides uniform observability and extensibility, and also fine-grained access control and encryption between microservices. The third layer on the top of that is a control plane. This control plane allows you to have a single pane of glass across all your clusters, no matter where they are running, whether they are on-prem, one cloud, public cloud, another public cloud. You can see and visualize and control all of them from the single place. It also provides you the ability to do fleet-wide logging and monitoring. So all the data can be accumulated and visualized and controlled from the same control plane. It also gives you many advanced security features. For example, stack driver, binary authorization, and many advanced features for security and logging. And I'm going to walk you through those features in the next slide. So the next layer on the top of is config management. So we call it Anthos config management. And it basically is the policy as a code. The configs are automatically synced across all your Anthos clusters which are registered and continuously enforced. And the final piece of tech here is the marketplace, which allows one-click deployment of the Anthos app which are available on the marketplace on any Anthos clusters that's running. And not only that, you can also do lifecycle management of all the apps you have installed using the marketplace. So with that, you get a comprehensive platform for your hybrid and multi-cloud environment, which is rich in security features. So now, let's look at the security features. So Anthos provides you the state-of-the-art security capabilities. And it takes a holistic approach to the security and reduces the risk every step of the way. So starting from the secure distribution out of the box, it enables security and it takes secure by default approach. Next, it provides many advanced features which mitigates the risk that is faced by your AI/ML workload. For example, it gives you managed curated base images. These are curated by Google engineers. It also gives you basically vulnerability scanning capabilities. So all your images can be scanned for known vulnerabilities so that they don't go into production for the known vulnerabilities that we are aware of. The third cool feature is binary authorization. What it means is that every image that is running in production has to be signed cryptographically, then and only then it's allowed to be running in the production. Any image that's not signed by cryptographic hash will not be allowed to run in production. The next cool security capabilities are basically reducing the security risk in a communication channel. The way it does is basically allows you mutual authentication and authorization of communication channel between any two microservices. And the entire communication channel between the microservices is fully encrypted. So with this way, you can secure the data that goes between the microservices. The third cool capability is basically reducing the security risk at the runtime. And this is done by runtime integrity checks, runtime sandboxing, and runtime threat detections. It also mitigates the security risk for data exfiltration. And the way it does is basically we provide you VPC service control. That's a feature that's available which mitigates the risk of data exfiltration. It also provides you identity aware proxy. So that way it can basically ensure that identity that is used to access certain data matches the requirements and the policy. It also provides you context aware access. So that's how we can reduce the security risk. And all of these features are part of the Anthos bundle, so you can actually get it out of the box. Now, most of the organizations today have many teams working in the parallel, and they have many clusters. Some are used for development, some are used for production. You have different clusters on-prem versus cloud, and if you have multiple clouds, then multiple clusters running everywhere. So in that kind of environment, how do we consistently apply policy and enforce the policy? That's a big challenge. And Anthos config management is designed to address that challenge. So the way it works is you author your policy, the policy gets synced with the Git repository, and from there on, it's automatically synced across all your Anthos clusters. And it's continuously enforced. So that way, you just have to author policy once, and it's applied everywhere where Anthos clusters are running with just one click. It also offers you certain additional benefits. So now your policy is auditable, it's revertible, it's transactional, and self-healing. So the whole policy management and the security aspects becomes much, much simpler, even though you may have many, many clusters running all across the multiple clouds as well as on-prem environment. Next piece as we talk about is the Anthos service mesh. This is Google's implementation of Istio, and basically it makes it super simple and easy to basically connect and secure your microservices. The way it works is it has a very, very lightweight proxy containers which get attached to your microservices. And this proxy basically intercepts all the communication going across the microservices and enforces your policy that you have set up for your organization or a particular workload. So this is a critical piece, and it provides 3 core benefits. So number 1 is it gives you uniform observability across all your microservices and across all your clusters, which is very, very important for security threat mitigation. And also basically triaging any kind of issues your microservices are facing. Second, it gives you traffic shaping, circuit breaking, fault injection, A/B canary rollout, etc. capabilities, which basically improves your operational agility. So you can move fast, you can bring the workloads faster on the production, and you can mitigate the issues that you are facing in production much sooner. The third very, very important capability is policy-driven security. Here we basically encrypt all the communication channels, and you can set the policies what happens to your microservices from the security point of view. So you can enforce mutual authentication, etc. policies. So with Anthos Service Mesh, your developers don't have to worry about hard coding configurations like, for example, rate limiting or quota and things like that. They can just use those capabilities out of the box using Anthos Service Mesh. Instead, they can focus on developing the features that add business value. So that takes a lot of burden away from your developers and improves your developers' velocity. So as we talk about, Anthos basically helps you solve many, many MLOps challenges. However, there's one challenge that still remains, and that's the following. So Anthos speaks Kubernetes APIs. And as many of you may be familiar, many cloud providers or resources do not speak Kubernetes APIs. So now you have to learn multiple API frameworks in order to make use of cloud providers' resources together with your ML operations. So how do we solve that challenge? Fortunately, we have developed Kubernetes config connector, which is basically a plugin for Kubernetes clusters, and it does the translation between Kubernetes API and the cloud provider's native APIs. So this way, you are, as an ML ops person or as a developer, you can just speak Kubernetes API and use declarative processes and GitOps and the tools that you are familiar with. Kubernetes is a fabulous ecosystem of tools. So you can make use of all of that, and this config connector will do all the translation between a Kubernetes API and cloud providers' native APIs. So for example, if you are in a Google Cloud, we have a fabulous database called Spanner. Now Spanner speaks RESTful APIs. But if you are a Kubernetes native developer, you may want to access Spanner for your ML operations using Kubernetes style API. And with config connector, you can continue to do so. You can make use of declarative processes that you are very familiar with to run all the operations, even though behind the scene, the APIs are different. So with Kubeflow on Anthos, we are providing you a very, very powerful platform that empowers your team to drive innovations. So we are basically making it really simple for MLOps team with the help of auto provisioning and auto scaling that is standard within GKE. GKE stands for Google Kubernetes Engine. We are making MLOps simple by providing a platform that you can use across hybrid and multi-cloud environment with the help of Anthos. And we are promoting the GitOps style declarative repeatable processes, which basically reduces the burden on the MLOps team for running operations. We are also making MLOps secure by enhancing the features such as uniform observability across all your microservices with the help of Anthos Service Mesh, Another cool feature is policy as a code, and with the help of Anthos config management, so your policies get synced across all your clusters. We already talked about many other cool security features like binary authorization, vulnerability scanning, mutual TLS, metadata concealment. Many other advanced features are also part of that offering, which makes ML operations much more secure. We also making the MLOps cost effective by helping you avoid vendor lock-in with the open source platform. So which means the developers can write once and deploy the same code everywhere where Anthos is running, and that way you don't have to lock in yourself into one vendor. We also offer preemptible GPUs and TPUs, which cost almost 1/3 of the on-demand GPUs, TPUs. So for ML operations, training, inferences, the cost of using the infrastructure will be much, much lower.
All right, so this is the logon screen for Kubeflow. And so one of the things we've done is that if you log in and you don't belong to a namespace, we're automatically going to provision one for you. So we're walking through this little flow. So here's the central dashboard for Kubeflow. And the main thing here is that, as we said before, Kubeflow is trying to make it easy to organize those applications into a cohesive platform. So the main idea with our central landing page is that you can easily navigate among all the different applications in the stack. So up at the top, we have pipelines. So that's our orchestration tool. So I think Orita and some of the other folks already showed pipelines. So I'm not going to go too deep. We also have notebooks. So from here, we can manage and deploy notebooks. Then down here, we have Katib, which is our hyperparameter tuning system. And then finally, we have our metadata store or artifact store. And so this is where we can see all of the data sets and models that we've logged in our tracking, as well as artifacts and data sets. So in this particular example, we're going to go over to the notebook server. Sorry, the light's in my eyes. It's hard to see. And so from here, we're going to select the namespace that we want to run in. So here we have the existing namespace, and we can see we have an existing notebook running, so we can just go ahead and connect to it. And that's so we've just launched that, and now we're launching into a Jupyter notebook. I'm just going to go ahead and open up my notebook. And this is a very simple notebook. And the main thing that we're trying to illustrate with this notebook is how easily it is with Kubeflow to build, train, and deploy from a notebook, but taking advantage of Kubernetes to do that. So can you zoom in a little bit, just on the text? Yeah, there we go. Great. So if we scroll down here, we have our training code. And this is just straight Python code like you would normally write in a notebook. And then really the only thing I want to call out here is the fact that we have these logging statements right here, where we're doing like log output. And essentially what we're doing is, as part of our Kubeflow metadata story, we provide a Python client library, very similar to the built-in logging library. And that allows you to add logging statements that will track information about your model or artifact. And those will get written to the metadata store, which is that UI I just showed you. And that way we can track all of the artifacts that we're producing. Then we also have our predict code down here. And again, it's just the straight Python code. And in this particular case, we're just using the XGBoost library and invoking the XGBoost code to train a model and predict a model. And so here, we're just invoking that training code inside our notebook. And so now we can easily run training inside our notebook like we normally would. But now what we want to do is we're going to take advantage of Kubeflow and in particular SDK that we've written, which we call Fairing. And what Fairing is going to make it really easy to do is it's going to take this notebook, convert it to a Python file, and build a Docker image, and then launch that on a Kubernetes cluster. And so all we have to do there is, if we scroll down, we instantiate this what we call a preprocessor, and the preprocessor is what's going to take our notebook and convert it to a Docker image. And we just call preprocess on that in order to build that Docker image. And so now we can go ahead and launch that as a Kubernetes job. And again, to do that, we just use Fairing, and the Fairing client library makes it so we just instantiate a job object, and then we call deploy on that job. And so now we're invoking that same training code, except now it's going to be running on our cluster as a Kubernetes job and not inside our notebook. And so this has a couple key advantages. One is, if we want to scale out to the full data set, we can launch this as a separate job on the Kubernetes cluster and use a GPU. And once that job is finished, it will release the GPU and not hog those resources, unlike running in the notebook, where the notebook would continue to run after the code finishes executing. We could also run that in a loop if we wanted to run multiple jobs in parallel to train on different hyperparameters. So I'm going to cut the demo there since we're already out of time. Any more questions?
To do Kubeflow on-prem install on the existing cloud is somehow very challenging because like every company, we do things, we have a Kubernetes cluster, but we do things slightly different at a lot of component level. So I want to ask, is it possible to have a version of mini Kubeflow, only have the essential component, all those things is just customer resource, you just install a deployment on the existing Kubernetes cluster without other assumption on the authentication layer, how do you do service mesh, and all those other things?
So, I think the problem here is that, so the question was, Kubernetes is like a sort of a leaky abstraction. So, typically to have a really good, Kubeflow and machine learning platform, you need to have other services integrated like IAM auth, logging, storage is a big one. ML is all about data. And so, typically where we see a lot of pain and difficulty around installing Kubeflow, it's about integrating with those systems. And that's going to be different for every sort of system. But what we're sort of seeing, at least in like the different platform vendors, whether those are the cloud vendors or they're people delivering on-prem solutions like Canonical, we're seeing those folks are sort of taking the lead and making sure they have like a really solid reference architecture and making sure that everything works well with their stack. And so if you're on one of those stacks, then you should have a should hopefully have a smooth experience. But if you are doing something custom or you are using different components or customizability, then you will have to do some work to make it all deployed and integrated. All right, thank you very much.